Good evening, geometry students. This is Coach DePaulo here for a video for the second lesson in Chapter 5. This lesson is called Classifying Triangles and also Remote Exterior Angles. This lesson is going to be doing a few different things. The first thing we're going to do is we're going to take the Pythagorean theorem and we're going to use it in a different way than we've ever used it before. So normally what we've done is if I gave you a right triangle like this one right here, and I told you that, say, this was 5 and this was 10, and asked you to find x, then what you would do is you would write x squared plus 5 squared equals 10 squared, and use the Pythagorean theorem like that to solve for x. But what we're going to do today is we're going to take 3 sides of a triangle, and we know all 3 sides, but we're going to classify that triangle as being an acute triangle, an obtuse triangle, or a right triangle. Now, before we get started on that, understand that an acute triangle is a triangle similar to this one, where all 3 angles, angle 1, 2, and 3, are acute. So all the angles in the triangle are acute. Now, the obtuse triangle would look something like this, and in an obtuse triangle, only one angle is obtuse. The other 2 have to be acute, but it has one obtuse angle. And then, of course, we already know that a right triangle is a triangle where the largest angle is 90 degrees. So, and what I've done is I've given you 2 sets of acute triangles, or two acute triangles, 2 obtuse triangles, and 1 right triangle, and I've given you the side lengths of those triangles. And what I want you to do is we're going to put those in the Pythagorean theorem, with the 2 smallest sides being A and B, and the longest side being C. And we're going to compare the sum of the A squared and the B squared with C squared. And we're going to see if we can find a pattern. So first up, we're going to take 5 and we're going to square it. And then we're going to add 8 squared. Now, real quick, let me go ahead and make that just a little bit bigger so we can all see it. So 5 squared plus 8 squared, and we're going to get us a value for that. And then we're going to do 9 squared. Now, we know 9 squared is 81. And so then 5 squared plus 8 squared happens to be 89. And if I compare those, I'm going to compare the 89 and the 81. 89 is greater than 81. Okay, now let's go to 7, 12, and 13. So 7 squared plus 12 squared, using our calculator, that's going to be 7 times 7 is 49, and 12 times 12 is 144. When I add those up, I'm going to get 193. And then 13 squared is 169. So we're going to compare 193 to 169. And again, those 2 add up to a number bigger than C squared. All right, next up, let's look at the 2 obtuse triangles and see if we see a pattern. So we're going to go 8 squared plus 11 squared. Now that's going to be 64 plus 121, which is 185. And then 14 squared, that's 196. So we're going to compare 185 to 196, and that is less than. All right, and then let's look at the other obtuse triangle. We're going to take 9 squared, and we're going to add 12 squared. So that's 81 plus 144, which is 225. And then 16 squared, that's 256. So we're going to compare 225 to 256, and notice that that again is less than. And then lastly, we're going to look at our right triangle, and we've got 6 squared plus 8 squared. That is 100. 10 squared is also 100. So we're going to compare 100 to 100, and we're going to say that those are equal. All right, so what I'd like you to do is I'd like you to pause the video right here, and I'd like you to write down a relationship between a squared and b squared, and how that compares to adding those up, and how those compare to c squared for each different type of triangle. Okay, well, hopefully after that slight pause, you have found a pattern. And for the acute triangle, I hope that you saw that a squared plus b squared was greater than c squared both times. Okay, for the obtuse triangle, I hope that you found that the a squared plus the b squared was less than the c squared both times. And then the right triangle, we've already known this for quite a while, but we already know that the a squared plus the b squared is equal to the c squared. So let's go on down here, and we're going to put those in a rule. However, more often than not, if I asked you to choose a symbol, acute, greater than, less than, or equal to, and I said, which one would you associate with the word acute? You probably would say less. And which one would you associate with the word obtuse? And you'd probably say greater, just because obtuse is a big angle and acute is a small angle. So that's one of the reasons why when we start using the Pythagorean theorem to classify triangles, we actually reverse the order of the formula or the theorem. And so we're going to look at when c squared is greater than a squared plus b squared. Okay, and so when is c squared greater than a squared plus b squared? So if we look back up here in our chart, c squared is greater for the obtuse triangles. And we're going to notice that c squared is less for the acute triangles. So if we look here at our formula, here's what we're going to say. If we compare c squared to a squared plus b squared, okay, if c squared is greater, then that's going to be an obtuse triangle. And when c squared is less, that's going to be an acute triangle. And then right here, I like it better to leave the order. Sometimes you'll see it a squared plus b squared equals c squared. But since we're putting both of them, the first two, in reverse order, I like to go ahead and leave this one as well. So when is c squared equal to a squared plus b squared? When the triangles are right. Okay, so let's go down here and let's practice one. I'm going to do A, and then I want you to do B and C. So first off, we need to make sure that we choose the two smaller ones for A and B, the third one for C. And so we've got 8 squared, we've got 20 squared, and we're going to compare that to 8 squared plus 18 squared. Now, 20 squared we know to be 400, and 8 squared is 64, and 18 squared is 324. And when I add those up, I get 388. So 400 is greater than 388. And we know that greater is obtuse. So this will be a obtuse triangle. All right, I want you to pause the video, and I want you to try B and C. All right, so let's see. Hopefully you've already finished these and you're just checking. So you should have compared 65 squared to 16 squared plus 63 squared. And so you should have got 4,225 for 65 squared. And then you should have got 256 plus 63 squared is also 4,225. So these are equal, and equal means that we have a right triangle. All right, and then letter C. Let's see, we got to make sure we pick the largest one is 16. And we got to compare that to 6 squared and 15 squared. So 16 squared is 256, and 6 squared plus 15 squared is 261. And so that is less than, 256 is less than, which means I have an acute triangle. All right, so just a reminder right there, when you reverse the order of the Pythagorean theorem and you put the C first, when C squared is greater, it's obtuse. When C squared is less, it's acute. And when C squared is equal, it is right. All right, so if you want to, pause the video, go to your homework, and start doing the problems that deal with Pythagorean theorem. Come on back, and let's go to the next page. All right, so in the next page, we're going to be able to learn how to determine which angle in a triangle is across from the largest side. We're going to be able to classify the sides from largest to smallest if we know the angles, or we're going to be able to classify the angles from largest to smallest if we know the sides. So first thing I'd like you to do here in letter 2, it says list the angles in order from least to greatest. So the angles in order from least to greatest, so the 37 is the smallest, and 60 is the medium, and 83 is the large. So in order from least to greatest, the angles are 37 degrees, and then 60 degrees, and then 83 degrees. So that would put angles C and B and then A. Okay, so now let's look at the sides. Which sides are the biggest? So let's see, the longest side that I have is 43, so this is the longest side. The medium side is the 38, and the shortest side is the 25. So then, what links do I have for that? Let's see, I've got smallest to greatest is 25 centimeters, and then 38 centimeters, and then 43 centimeters. Now, if I look at the sides, this is side AB, this is side AC, and this is side CB. Okay. And what I'd like you to notice is if you look over here at our picture, and if I start at the angle and draw an arrow from the angle across to the side, you're going to notice that the smallest angle is across from the shortest side. The medium angle is across from the medium side. And the largest angle is across from the longest side. Okay, and so that is true for all triangles. So we're going to write a conjecture, okay, or we're going to take that observation and write it into a conjecture, and we're going to say that in any triangle, the longest side is opposite or across from the largest angle. And then we can also say in any triangle, the shortest side is opposite the smallest angle. And this also works in the converse. So conversely, I could say that the largest angle is opposite the longest side, and the smallest angle is opposite the shortest side. Okay, so let's look at these questions then real quick. Number 4 says, a landscape architect is designing a triangular deck, and she wants to put down some benches, and she wants the benches to be across from the largest corner or the biggest angle. So let's go ahead and look, but I don't know the sizes of the angles, but I do know the length of the sides. So I'm going to start at each angle, and I'm going to draw a line diagonally across the triangle from the sides that they are opposite. And I'm going to look for the largest side. So this side right here is the longest, so it must be across from the largest angle. So it's across from C. So we're going to say that the benches will go at angle C. All right, next up, we've got a problem where we got to draw our own triangle. We got to put some information in it. And then it says, list the sides of the triangle in order from shortest to longest. Okay, so first up, we're going to draw a triangle. These triangles do not have to be drawn to scale. Okay, so we're going to put some information in here. We're going to say that angle R is 50 degrees. We're going to call this R. And angle S is 60 degrees. So since it's RST, this must be angle T over here. So remember that every triangle has 180 degrees. So we're going to take 180 degrees and subtract 50 and 60. And that's going to leave us 70 degrees. So that must mean that angle T is 70 degrees. And now we want to look at the largest, or the sides from shortest to longest. So I'm going to do my little angle thing again. And I'm going to start at 50 and go here. Start at 60 and go here. Start at 70 and go here. So the shortest side is opposite the smallest angle, which is 50. So the shortest side is right here. So first up is ST. Then the medium side would be opposite the 60-degree angle. So that would be RT or TR. And then the longest side will be opposite the largest angle. And so that's going to be SR. All right, let's go on over here and do this one. So same thing, I want to list the angles in order from largest to smallest, but I don't know all the side lengths. So first up, look here, I got a right triangle. So how do I find the missing side of a right triangle? Well, we just used it earlier. It's the Pythagorean theorem. So the first thing we're going to do is we're going to call this x, and we're going to say x squared plus 7 squared is 25 squared. So this is going to be x squared plus 49 equals 225. Subtract 49 from both sides, so x squared is going to be equal to 625. My bad. 625. So that makes this 576. So then x is going to be 24 after we take the square root of both sides. So now I know that x is 24. So I'm going to do my angle thing again. I'm going to start at angle P, go over here, and angle U, and go over here, and angle C, and go over here. So the longest side is 25, so that means this is the largest angle. The medium side is 24, so that must mean C is the medium angle. And P is across from 7, which is the smallest side, so P is the smallest angle. So I want to list the angles starting at the largest one. So my largest angle is U, so angle U, then angle C, then angle P. All right, now we're going to do something very similar. We're going to come down here, except now we're going to compare two triangles. So we've got to look at both of these and figure out what's the longest side and what's the shortest side. So first thing I'm going to do is I got a 30 and a 90. That adds up to 120, which means this must be 60 degrees. Okay, and then these two right here, these add up to 120. So this must be 60 degrees. Okay, so now looking at triangle TSQ, I'm going to do my angle thing again. 30 is my smallest, so this is the shortest side. 60 is the medium, so this is my medium side. And 90 is the biggest, so this is my longest side right there. Longest side. All right, then in triangle TQR, 45 is the smallest angle, so this is the shortest side. 60 is the medium, so this is the medium side. 75 is the largest, so this is the longest side. So then where's the longest side between both of these triangles? Well, if the longest side of this triangle is TQ, but that's the shortest side of triangle TQR, that must mean this side is the longest of both of them. So my longest side is TR. So that must mean that the shortest side must be here. Let's see, how do I know? Let's see. So this is the shortest side of this triangle. This is the shortest side of this triangle. Okay, well, this one, ST is definitely shorter than TQ. So we're going to say ST. All right, and then same thing on this side, okay? We'll do it one more time. Starting with SPQ, 75 and 35 is 110. So that must mean that this one is 70 degrees. So again, while I'm here, I'm going to go ahead and do my sides. This is the shortest side. Sorry, the smallest angle across from the shortest side. 70 is the medium angle, so this is the medium side. 75 is the largest angle, so this is the longest side. Okay, go back to now. Let's look at SRQ. 70 and 45 is 115, which makes this 65 degrees. Okay, so I'm going to now do my angle thing. 45 is the smallest angle, so it is across from the shortest side. 65 is the medium angle, so it's across from the medium side. 70 is the largest angle, it's across from the longest side. So the same kind of thing plays out. The longest side of this triangle is SQ, but that's the shortest side of the other triangle, so then this longest side must be the longer of the two longs. So this is going to be SR. And then that makes the shortest side SP. All right, so again, if you would like to, go ahead and pause this video. We got one more page to go, but pause the video and go to your homework and attempt to do some problems there that are similar to this page by classifying angles, small, medium, and large, and sides, small, medium, large, and then come back to the third page of notes. All right, here we go, last page. So this page of notes is going to be dealing with something called the remote exterior angle theorem. Okay, and so first off, we need to classify some terms. So over here on this triangle, we have three angles, 1, 2, and 3. And then what I've done is I've extended one side. And by extending that side, I've created angle 4. And that is called an exterior angle. So angle 4 is called the exterior angle. All right, now, out of angles 1, 2, and 3, angle 1, this is the adjacent angle to the exterior. So this angle 1 is adjacent. So that means that these two angles, angle 2 and angle 3, these are known as the remote interior angles. So these two angles, I like to use the word remote, meaning long, like a far from anything. You're in like a remote place. So these two angles are the farthest away from 4. So those are called the remote angles. Now, this angle has a relationship to these two angles. And Miss Miller has a great video. If you go ahead and look at her video at the very beginning of it, she does a great explanation of this relationship. I'm going to do the relationship algebraically because I don't have the materials that she did. So first I'm going to do is I'm going to look at angle 1 and 4. Okay, so we know that these are a linear pair because they add up to this straight line. So we know that angle 1 plus angle 4 add up to 180 degrees because that's what a linear pair does. And now what I'm going to do is I'm going to subtract angle 1 from both sides. And so it turns out that angle 4 is equal to 180 degrees minus angle 1. So I'm going to circle that. Okay, now let's go over here and look at the triangle. Inside a triangle, we know that angle 1 plus angle 2 plus angle 3 equals 180 degrees because all triangles equal to 180. So let's move angle 1 over to the other side just like I did just a second ago. If I rewrite this, it turns out that angle 2 plus angle 3 is equal to 180 degrees minus angle 1. And what do you know? Turns out that angle 4 is the same as the measures of angle 2 and 3. So the exterior angle is equal to the sum of the two remote interior angles. And that's called the triangle exterior angle theorem. So we're going to fill it in. The exterior angle of a triangle is equal to the sum of the two remote interior angles. Okay, so now we've got a couple of examples down here. So let's do example number 1. Okay, so example number 1, I've got here is the remote, or this is the exterior angle right here. Okay, these are the two remote interior angles. Okay, so we know that angle X is equal to 61 degrees plus 39 degrees. So the X is equal to 100 degrees. All right, and then we're gonna skip number 48. We're not gonna do number 48, but we are going to do 11 and 13. Okay, so on number 11, I've got two actually exterior angles. I've got this one right here and this one right here. Okay, but I'm trying to solve for y. So what I'm going to do is I'm going to concentrate on this one right here. In order for me to find out y, I need to know how big is this angle and how big is this angle. So I'm going to use some previous knowledge. First thing I'm going to do is I'm going to put 57 degrees right here. And I'm going to do that because I'm going to remind you that this is a vertical angle with this 57. Those are vertical. So those are equal to each other. Okay, then over here, I have a linear pair. Okay, so I'm going to write linear pair right here. And we know that a linear pair adds up to 180, so that must mean this is 70 degrees. So now I can write my equation. Here's the exterior, here's the two remote interior, so I know y plus 10 is equal to 57 degrees plus 70. So y plus 10 is equal to 127 degrees. So I'm going to subtract 10 from both sides. So it turns out that y is equal to 117 degrees. All right, and then last one. Here we go. Got a little algebra on this one. Okay, here we go. This is my exterior angle. These are my two remote interior angles. So the equation will be 5x plus 50 equals 3x plus 7x. So 5x plus 50 equals 10x. I'm going to subtract 5x from both sides. So it turns out that 50 is equal to 5x. And then I'm going to divide both sides by 5. So it turns out that x is equal to 10. Okay, well, that's the remote exterior angle theorem, okay? And now this one down here, we're going to save that for another day. This is actually a review problem, so I'm going to do that in class with you the next time I see you. And these notes are long enough, so we're going to go ahead and stop right here. If you have any questions, come on and get some help. And now that you've finished watching the video, you can go do practice 5.2. Hope you have a great night.